Right. Hello, students. Today we will learn the basic concept of root finding. This is the first topic of the course, numerical computation. Okay. Now, when we talk about root finding, basically what is in our mind, we want to find the root of a function, means that we want to find the point at which the graph touches the x-axis. Please keep it in your mind. Okay, so there are now two types of root finding methods: open methods, closed methods. Okay, we will follow the book Stephen C. Chopra for the closed methods, chapter 5, for the open methods, chapter number 6. Okay, so next, let me talk about the first method that we will learn today. Bisection method is an example of the closed method or the bracketing method. Bisection means you will divide the given interval into equal sized subintervals. Okay, and closed method means that an interval will be given to you. By close, I mean to say that a bracket or a closed interval will be given to you. Let us talk about the first question. I have x square minus 4. I want to find its root using the bisection method in this interval 0, 3. This is a closed interval. Okay, so before we learn the bisection method, we will first introduce the root finding method with the help of the graphical analysis. Okay, so let me say that I have here x is any interval, and it has got the lower bound -5, a step size 1, and the upper bound 5. Then I have another function y, which is defined as x square minus 4. Okay, and you can do these calculations on your calculator. Otherwise, you can also install the software called MATLAB, and you can solve the problem with me. Okay, otherwise you can do it manually. All right, so bring a notebook, a pen, and a calculator, scientific calculator. Okay, now what am I going to do? I will plot this graph, and I will plot the x-axis as well. I know that along the x-axis y values are 0, so I have written this command here. Let me see how it looks like. So here you can see, students, this is actually the equation of a parabola, right? So we can see that this is the graph. The blue sterics are the graph of the function x square minus 4, and the red line is y. X is you can see that y is equal to 0, the x-axis. Now the graph touches the x-axis at 2 points, -2 and +2. So these are the two roots of the given function. Now let me look at the question carefully. The question says that I have the closed interval from 0 till 3. So let me correct my interval. So I'm going to edit the x. The lower bound is 0, the upper bound is 3, and I will put the step size 0.1. Okay, why? Because I want to make a better picture. Okay, so now I will have y, and now I'm going to plot it. Now let us look at the graph. Can you see here, students? I can clearly see that inside the interval from 0 till 3, I have a point at x is equal to 2, y is 0. This means x is equal to 2 is the root of x square minus 4. Very, very trivial answer using the graphical interpretation, right? So by sketching the graph, I have obtained the root. Now let us apply bisection method on the same problem. Before we apply the bisection method, we need to learn the bisection method. All right, so let us understand the bisection method with the help of the important steps. Okay, so let me open the definition of the bisection method. Okay, so what does it say? We have got this definition of the bisection method, it says that given a function is continuous, the function must change its sign in the interval. Only then we can apply the bisection method. Now, this is also called the intermediate value theorem. Okay, so we are actually saying that, for example, in the given question here, you can see I wanted to find the root of x square minus 4 in the closed interval 0, 3. So if I want to apply the bisection method, the first step is that I want to verify f of 0 times f of 3 is less than 0. Only then I can apply bisection method. So let us verify it. So let me define another function z, or let me call it f or z, whatever. Okay, and let's call it z to be more consistent. So I'm saying that z of 0 is minus 4. If you put here 0, you will say 0 square minus 4 is minus 4. Okay, then I will say z of 3. If you put here 3, what will happen? 3 square 9, 9 minus 4. What is it, students? 9 minus 4 is 5. Okay, so I have here z of 3, 5. So now I will multiply z of 0 with z of 3. It is a negative number. Okay, z of 0 times z of 3 is a negative number. So therefore, I can apply the bisection method. So the first step says that function is continuous and functional value at the boundaries is the product of the functional values at the boundaries is a negative number. Then the intermediate value theorem is satisfied. Then you can apply the bisection method. Next, go to the next step, bisection. So bisect the intervals A, B. So for example, in your case, you are given 0 till 3. Okay, so you can see that here we have got 0 till 3. Okay, so what is the midpoint of this interval? 0 plus 3 divided by 2 is 1.5. So the midpoint is 1.5. Okay, so we have here an interval okay. I have this big interval. I have here 0. I have here the midpoint 1.5. And I have 3. The first prerequisite was that check f of z of 0, z of 3 is less than 0. Correct. That was correct. Now I have divided the interval into two parts. I have got now two subintervals, 0 till 1.5 and 1.5 till 3. So now let me first check the functional values in this subinterval. Okay, so I want to check z of 0 times z of 1.5, whether it is a positive number or a negative number. So I will check z of 0 and z of 1.5. Their product is 7. Now what is z actually? Z is x square minus 4. Here you will get the value minus 4 and here you will get another value. So 7, which is greater than 0. So students, you will say that here you have z of 0 times z of 1.5 is greater than 0. Intermediate value theorem said that the product of the functional values at the boundaries must be less than 0. I repeat, the product of the functional values at the boundaries must be less than 0. Here it contradicts with the intermediate value theorem. So I will say intermediate value theorem fails. So discard this interval. Okay, let me discard it. So I'm going to say that this is not the desired interval. Okay, discard it. Now go to the next part. The next subpart is here, written here. 1.5 and 3. Now I want to check that whether, now because you are learning it, so for your ease, I will write here what is Z. Z is actually x square minus 4. Now Z of 1.5 is what? Z of 3 is 3 square minus 4, which is 5, and z of 1.5. Use your calculator. 1.5 square minus 4. Okay, so z of 1.5. This is minus 1.75. Let me write it here. This is minus 1.75. Now we will have z of 1.5 times z of 3. I am multiplying the functional values at the boundaries of this new subinterval to check whether the intermediate value theorem holds or not. So I can see that from here, and you can use your calculator, and or you can install a MATLAB. Okay, so I'm going to check that z of 1.5 times z of 3. If it is a negative number, I will keep this interval. Okay, otherwise I will discard this interval. So let's see. Now the answer is a negative number. Okay, so you will, it is a negative number, so you will say keep it. Okay, now go to the next step. What is the next step? The next step says that you will now, your main interval is now this interval 1.5 till 3, and what are you going